Okay, my MathCounts friends, here we go. We've got warm-up number 7 from the 2026 problem set. There are some doozies in here. Starting with number 1, make sure you read it completely because I did not the first time. I couldn't figure out why I wasn't getting the right answer, and then I read it again. And it was much easier than I was making it. I did like a full page of work because I thought it was saying something else. Anyways, Katie rolls 2 fair-sided 6-sided dice and records the positive difference between the numbers only if the 2 dice show different numbers. If both dice show the same number, she doesn't record anything because it's just 0, right? James then rolls a standard 4-sided die, just one of them, not 2, because that's what I thought it was saying before because I didn't read, because words are hard. What's the probability that James and Katie obtain the same number? Express your answer as a common fraction. All right, so you got Katie. She's rolling 2 dice. The first roll and the second roll. Roll 1, roll 2. She can get a 1, 2, 3, 4, 5, or 6 on the first roll, and the same with the second roll. All right, so if she rolls a 1 and a 1, that's 0. That's nothing. If she rolls a 1 and 2, that's a difference of 1. 1 and 3, difference of 2. 3, 4, 5. And we can keep filling this out. If I go the other direction, a 1 and a 2 is a difference of 1, then 2, then 3, then 4, then 5. We're just doing the difference between the rolls. If she rolls a 2, then she rolls a 2. That's no difference at all. A 2, then a 3 makes a difference of 1. A 2, then a 4 makes a difference of 2, then 3, then 4. Going the other way, it's 1, 2, 3, 4. You'll start to see the pattern. 3 and 3 is no difference, and then it's 1, 2, 3, 1, 2, 3. A 4 and a 4, there's no difference. 4, then a 5 would be a difference of 1, and then 4 and 6 is a difference of 2. Same thing going here. Hopefully you're noticing the pattern. 5 and 5 is nothing. 5 and 6 is 1. And then 6 and 5 is 1 right there. And then no difference here. All right, so there's 36 rolls. There you go. So that is Katie. And then you got James. He's rolling a 4-sided dice. He can roll a 1, a 2, a 3, or a 4. So 25% of the time, he's rolling one of those numbers. So they all have a 1/4 chance. Okay, so we want the probability. What do we want? The probability that they have the same number. So she's just looking for the difference. So the only way that this can happen, if she has a difference of 1, if she has a difference of 1, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 out of 36 ways to get a difference of 1. He has a 1/4 chance of getting a difference of 1. I would definitely go ahead and reduce these numbers first. This is 5/18. So we end up with 5 over, what's that, 72? 36, 72? So there's a 5 in 72 chance of her getting a difference of 1 and him rolling a 1. Then difference of 2. She has 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 36 chances of getting a difference of 2. He has a 1/4 chance of rolling a 2. We can reduce these by 4. 4 goes into this twice. 4 goes into 18 9 times. And 2 and 4 reduce. So we get 1/18 chance there. Did I reduce that right? Yeah, I did. All right. Next possibility is she gets a difference of 3. She has 1, 2, 3, 4, 5, 6 ways out of 36 to get a difference of 3 or 1/6. He only has a 1/4 chance of getting a 3. So we get 1/24. Last one, difference of 4. 1, 2, 3, 4. 4 out of 36, which is 1/9. And he still has a 1/4 chance of rolling a 4. So we get 1/36. Difference of 5? No, he can't roll a 5, so that doesn't matter. And zeros don't matter. So these are all of our possibilities. These are different outcomes, so we can just add these numbers together. It'd be nice to have a common denominator, which is 72. So 5 over 72. We do 72 times this one. It's 4 times, so we get 4 70-seconds. 24 goes into 72, what's that? 3 times? Yeah, 3 times. And 36 goes into 72 twice, so you get 2 70-seconds. So I've got 9, 10, 11, 12, 13, 14 70-seconds. I'm just adding them all up because they're different outcomes. And that's going to reduce to 7 over 36. Look at that. There's a lot of work there. But that's our answer, 7 over 36. They're not all going to be like that. So that's your answer. All right, the flag of a rowing club is a square shown at right, and all the diagonal lines are parallel. Okay. What is the portion of the flag that is shaded? Okay, so it's a 24 by 24 square. I split it up into 2 parts. I did this top section first. So what I'm going to do is I'm going to split it up, and I want the portion of the flag that's shaded. So 24 by 24, what's that, 576? Yeah. So there's a total area of 576, and I want to put up in my numerator the total shaded area. So I'm going to do it by subtraction. The area of this triangle here is half of that, 288. And if I subtract this side, what's left is the shaded area. So I'm going to subtract 1/2 of 12 times 12, which is 72. So 288 minus 72 ends up being 216, right? Yeah, 216 for that section. All right, on this bottom section here, I'm only going to look at this triangle here. The total area of that would be 16 times 16, which is 256. And I'm going to subtract out the non-shaded section, which would be 1/2 of 8 times 8. So half of 64 is 32. So 256 minus 32. So that ends up being 256 minus 32 is 224. 24. All right, so this is this shaded region, 216. This is the area of this shaded region, 224. All right, so if I add those two together, I get 440, right? 440? No, I did something wrong. Let me double check my work here. Oh, found it. I just did 16 times 16 to get 256, but the area is half of 256. So half of 256 is 128. I knew I had an error somewhere. All right, 128. All right, 128 minus 32 ends up being 96. Okay, so 216 plus 96 ends up being 312. Yep, 312. So 312 of it shaded. out of a total of 576, and then you just start reducing to your heart's content. You know, I did it maybe by twos first and got 156 over 288. There's probably somewhere easier to do this, and I did it by 2 again and got 78 over 144. Ooh, I think I did it by 2 again and got 39 over 72. And then what, 3 goes into both of those? Yeah, 3 goes into that one 13 times, and 3 goes into there 24 times. Whoa, lots of reducing, and that's our final answer, 13 over 24. You guys should have told me when I was doing that part wrong. All right, next. A florist is creating an arrangement using roses, tulips, peonies, and daffodils. The arrangement must include exactly 9 flowers with at least 1 of each type. And the order of the flowers doesn't matter. How many different combinations are possible? All right, so we're going to have 1 of each type. There are 1, 2, 3, 4 types. So that means 5 flowers are left over. So we got 5 flowers. And then there's 4 different types of flowers. And what we're going to do is called stars and bars or sticks and stones or whatever. So here's what I'm going to do. There's 4 different sections. So I'm going to draw 3 bars. So in this scenario, if this is roses, tulips, peonies, and daffodils, so like the section in between, we do 3 bars because this represents all the roses. This section represents all the tulips. This is all the peonies, and these are all the daffodils. So this combination would mean 5 roses, none of these, none of these, none of these. So I've got this, you use these stars and bars when you have an unlimited amount of the things that you're choosing from. And so you use the bars, you always do 1 less of the things that you're spreading out between. And so what we have is 5 items that are the same and 3 items that are not the same. And so we can do a combination with this one. We've got a total of 1, 2, 3, 4, 5, 6, 7, 8. So there's 5 dots, 3 bars. That's 8 things. But 5 of these are the same, so we're going to divide out 5 factorial, and 3 of the bars are the same. So divide out 3 factorial. So that would be all the different combinations where I could move 1 over here or 1 over there and keep on moving them around. We've got 8 items, 5 stars, 3 bars. That's 8 items. 5 of the stars are the same, so we're going to divide that out for all the combinations where it doesn't matter the order. And 3 of the bars are the same because the combination of those doesn't matter. So 5 and 8 reduce. I'm left with 8 times 7 times 6. And then 3 times 2. That together makes 6. 8 times 7 is my answer, 56. Stars and bars. Always a good one. Next, number 94. Mr. Campo asks the 30 students in his stats class what foreign language they are taking and records their responses in a pie chart. However, it turns out 2 of the students study both Spanish and Latin. That's crazy. And therefore got counted in both of those sectors. If the Spanish sector of the pie chart is 180 degrees, how many of Mr. Campo's students are just taking Spanish? Okay, so he made a pie chart 180 degrees. That means half the students are showing that they are doing Spanish. But when he did it, he double counted 2 of his students. So his pie chart is showing that he has 16 people in here. No. 16, because he's showing that he double counted 2 of his students, so this pie chart represents out of 32 students. So out of 32 students, he's got 16 doing Spanish because he double counted some students. So instead of doing 32 students, he double counted 2 of them. He has 32 total students. So on his pie chart, he's got 16 taking Spanish. Well, we're double counting 2 of those students. So let's take away those 2 students that are being double counted, and that means 14 are only studying Spanish. 2 of them are doing Spanish and Latin, but the only Spanish would be 14. I need a new piece of paper. Woo, number 95. Let's do it. All right. What ratio of the divisors of 6 factorial are also divisors of 2 to the 6th? Express your answer as a common fraction. Okay, so we've got 6 factorial, which would be 6 times 5 times 4 times 3 times 2 times 1. 6 is 3 times 2. 4 is 2 times 2. So the prime factorization of 6 factorial, we'd have 5 to the first. We got that one. We'd have 3 to the second. And then we'd have 1, 2, 3, 4 2's. So let's find out how many divisors we have. We would do 1 plus 1, 2 plus 1, and 4 plus 1, because for these ones we have to include not using it when we reorder all the different divisors. So this is 2 times 3 times 5. We got 6 times 5. There's 30 different divisors of 6 factorial. So we got 30 different divisors. 2 to the 6th, since there's 6 of those, there are 6 plus 1 divisors. There's 7 divisors of this one. So it would probably be easier to look at the 7 divisors of this number instead of all 30 of the divisors of this one. So let's look at the 7 divisors of this one and see which ones would go into 6 factorial. All right, so we would do 1 and 2 to the 6th, which would be 64. 2 and 32. 4, I'm only doing powers of 2 here. 4 and 16. And then 8 is our last divisor because 8 times 8 makes 64. All right, so which one of these will go into this number? Well, 1 definitely will. 2 definitely will because we have 2 to the 4th here. This is 2 to the 1st, so it's definitely going there. This is 2 to the 2nd, that'll go in there. This is 2 to the 6th, it will not go into here because we only have 4 2's. This is 2 to the 5th, that will not go in here, only have 5 2's. This is 2 to the 4th, so that'll go in there. This is 2 to the 3rd, so that'll go in there. So I have 1, 2, 3, 4, 5 divisors that will go in there. So we've got 5 over 30 divisors total, which is 1 out of 6. Next, what's the units digit of 202 to the 5th plus 2 to the 0 plus 25? Okay, we don't have to look at every single thing here. When we have 2 to the 1st, the units digit, I'm not even looking at these numbers, I'm just looking at the units digit. 2 to the 1st would be 2. 2 to the 2nd, the units digit would be 4. 2 to the 3rd would be 8. 2 to the 4th would be 16, so the unit digit would be 6. And then the process would start all over again because 2 to the 5th is 32, so I'd have a 2. And then we get 4, 8, 6, 2, 8. So when the exponent is a multiple of 4, when it goes in there evenly, then we're going to have 6 as our units digit. When there's a remainder of 1, we're going to have 2. Remainder of 2, we're going to have 4. Remainder of 3, we're going to have 8. All right, so this is going 2 to the 5th power. 2 to the 5th power is going to have a units digit of 2. Okay, 2 to the 25th power. All right, how many times does 4 go in there? 4 goes into 24, so this would go in there 4 times with a remainder of 1. So remainder of 1 is a 2. So my other number is also a 2 in the units digit. I'm only worried about the units digit. So this units digit would be 2. This unit digit would also be 2. So 2 plus 2 is 4. 97. Moving on. Point A has coordinates of 14, -4. Point B has coordinates of -10, 8. Point B is 3/5 of the way from point A to point C along segment AC. What are the coordinates of point C? All right, so here's how I might do this. I'd say here's A at 14, -4. Here's B at -10, 8. C is on the same line over here, and we want its coordinates from it. So from A, the x coordinates are decreasing by 24. The y coordinates are increasing by 12. Okay, but that's only 2/5 of the distance. So if the actual distance is x, 2/5 of the actual distance, let's call it d so we don't get confused. So 2/5 of the distance for the x coordinate is -24. So I would multiply both sides by 5/2. Can't see, can you? There you go. Okay, so the whole distance should be -12 times 5, -60. So if I start at 14 and I go a -60 distance, my x coordinate should end up being, oh wait, that's 2 5/2, 2/5, 12, 14. Oh, it's 3/5, not 2/5. Dang it. I knew I was doing something wrong. 3/5. All right, so 3 goes into 24 8 times. We get 40, -40. All right, so if I go from 14 and I subtract 40, this point right here should be where C is going to be. That would be -26. So I'm starting at 14. The full distance, instead of being -24, the full distance to this endpoint should be -26. I should move -40. For the y coordinate, we would do 3/5 of the distance between the y's is 12. So the actual distance multiplied by 5/3 on both sides. So that distance ends up being 20. So if I start at -4 and go the full distance of 20, this point should be 16. So our answer is -26, 16. It's taking forever. All right, we're almost there. Oh, this one's a brutal question. All right, 5 families, each with 3 teenagers on a camping trip. 7 teenagers are needed to go into town to buy supplies. The group must include at least 1 teenager from each family. How many different groups of 7 can be chosen? Now, I wish they would have just made it an easy problem and said, hey, we got 15 kids and we want to find out how many ways we can do 7 of them. Because then that would just be 15 pick 7 and we could finish it off. But this one we have to think through a little bit more. So we've got 5 families. 1, 2, 3, 4, 5. We're going to pick 1 kid from each family. 7 are going. So there's only 2 ways that this can happen. Either we have 1 kid from each family, and then we have 2 left over. Each of these families has 3. So what I could do is I could pick 2 from the same family. And that would mean that a whole family goes. All right, you follow me on that one? So if we do 5 from each family, or 1 from each family. 1 from each family, so that's 5. And then 2 from just one family. That would be one way to do this. Okay, so how many different ways are there for a full family to have 3 kids going from it? Well, there's 5 different ways. I could do all 3 from this family, 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 all 3 from this. That's 5 ways. Now the other 3 families, how many ways are there to pick 3 from this one? Well, there's 3 kids to choose from. There's 3 kids to choose from that family. There's 3 kids to choose from that family. There's 3 kids to choose from that family. So we've got 5 times 3 to the 4th, which is 5 times 81, which is 405. So there are 405 ways to pick all of one family and then 1 kid from the other families. The other way to do this is we can do 1 from each family, and then we've got 2 kids left over, and we can do 1 from one family and 1 from another. So 2 from 2 different families. Now, this one's a little bit weird. So this one, there's 3 ways to pick the first family, the 1 kid. There's 3 ways to pick that, 3 ways here, 3 ways here. So we got 3 times 3 times 3 times 3 times 3. That's picking 1 kid from each family. Okay, now this last part is, I've got 5 families. How many different ways are there to pick 2 from one of those 5 families? So the last section is, I have 5 families, but I want to pick 2, which means I'm not picking 3. So this is a 5 pick 2 situation. So this is 3 to the 5th. This is 5 factorial over 2 factorial, 3 factorial. So we get 5 times 4 divided by 2, that's 10. Whew. All right, I did not solve it this fast the first time I did it. All right, so 3 to the 5th is 243. And then times 10, we get 2,430. So there's 405 ways to where you have 2 from one family, and then 2 from 2 different families. There's 2,430 ways. Add those 2 together, you get 2,835. And if you got that in under a minute, I will be mad. So I get 2,835. I thought about this problem for, like, I left school yesterday. I just kept on thinking about this problem. It just wouldn't get out of my head. It's painful. All right, almost done. These are easy. All right, what's the sum of the distinct prime number divisors of 22 factorial over 20 factorial? Pretty simple one. So we would reduce this. We'd get 22 times 21 after reducing. 22 is 2 times 11. 21 is 3 times 7. So there are 4 prime factors of this, and we just add them together. 2 plus 11 is 13, plus 3 is 16, plus 7 is 23. That's our answer. And last one, we got an equilateral triangle. We know these 2 sides, and we want to know what this side is. Well, since it's equilateral, everything's equal. So we can write that 6x minus 7 is equal to 2x plus 5. I'll subtract 2x from both sides, get 4x minus 7 equals 5. I'll add 7 to both sides, get 4x equals 12. I'll divide by 4 and get x is 3. Okay, so x is 3. All these sides are the same, so let's just plug 3 into this. 2 times 3 plus 5 is 6 plus 5. 11. So this side's 11, and so are all the sides, because it's equilateral. So our answer is 11 feet. The end. Math hard? Don't cry. It'll be okay.